Welcome back, ladies and germs. Today, we're going to talk about trig identities. And I'm so excited because this is going to be one of the first times that you guys get to do real big kid spooky math, right? You guys, at the end of this lesson, are going to feel like legitimate math warlocks. It's going to be so tight. I'm serious. This stuff is so cool, you guys. This is when I think math really takes off for you, right? This is where your math careers are going to get started. You're going to look back on the day and go, you know what? Today was the day my math career really got started. I dabbled before, but today I became a math person. So look forward to your future pacts with a demon to unlock your newfound math powers. All right, so let's go talk about them. So you're going to say, Barton, first of all, what the heck is a trig identity? I already have my own identity. I have a very strong sense of self, being a teenager and all. I have a very clear picture of the person that I am and want to be. I don't need a new identity. This isn't one of those identities. An identity is an equation that's true regardless of which variable you plug in. And I shouldn't maybe say which variable you plug in, but of which value you plug into the variable. So this is true for any value of x or any value of theta. You want to maybe think about these more like a definition than you do perhaps a identity. So let me give you a couple examples of identities you might know. Actually, I don't know how many identities you do know. Never mind. You're going to learn a bunch. Here are some. So let's actually talk about ones you do know for sure. We haven't called them identities yet, but here's the ones you already know. So these are what are called reciprocal identities. So we know that sine of theta is equal to 1 over cosecant of theta. And then you can just flip this side and this side. You can put this over 1, flip it. And then it turns into cosecant of theta equals 1 over sine of theta. So we also have cosine of theta is 1 over secant, tangent of theta is 1 over cotangent, and they're reciprocals. So these are kind of equations you already know that you should kind of have memorized. I know that you guys hate memorizing stuff, right? You're like, Barton, do I have to memorize them? To which I will say no. You could always ask your mother or father politely, Mother, may I please get a tattoo? And then have someone irreparably pierce your skin with a tinted needle and place ink there for the rest of your life so that you can just look at a handy little chart on your forearm. You could do that. That's fine. But if you're going to do something like math or engineering or anything useful with math in your whole life, you're going to use these so frequently that you're going to want to just go ahead and memorize them. By the end of this unit, you're probably going to accidentally memorize them. But, you know, it probably couldn't hurt to sit and ponder them a little bit. At the very least, I would copy them down, maybe not in your notes, but like start a clean piece of paper and write them down, like label it trig identities at the top and copy this stuff down so that you have it in a nice clean spot and you don't have to go digging through your notes. And that way when we add more, say tomorrow, we could just amend it and put some more on the end. So no, it's not technically necessary, but if you're going to go to college and take calculus classes and stuff because your major requires it, they're handy to know. So there are your reciprocal identities. There are also two known as the quotient identities, and this is just tangent of theta equals sine over cosine, and then the reciprocal, because 1 over tangent is cotangent, right? 1 over tangent. If you flip this one, it's just cosine over sine. So you've got your two reciprocal, or your two quotient identities as well. So these are the 8 you should kind of already know. You probably know these ones, and then you can figure out the other 4 by just flipping everything upside down, right? So those aren't too bad. You probably already have them down. Here is one that you have probably heard of. If people know some random math facts, right? Some people know some random physics facts like F equals ma, or E equals mc squared. People just know these, like, for no reason at all. People typically know this one for no reason at all also. So sine squared plus cosine squared equals 1. Let me show you where this one comes from. And it's called the Pythagorean identity. So this name kind of gives you a hint where it comes from. So let's look at our unit circle, shall we? What color do you guys want it? How about blue? So we have our unit circle. And we know that the radius of the unit circle is 1. And we can break this up into a right triangle where this is the y coordinate, this is the x coordinate, and we have some really easy ways to calculate x and y. We know that cosine of theta, where theta is this angle right here, that equals x, and sine of that same angle equals y. It'll tell us how tall this triangle is. If we use the Pythagorean theorem on this triangle, watch what happens. So we have our two legs squared, so x squared plus y squared equals the hypotenuse squared, 1 squared. All right, that's good. So 1 squared is 1, and we just said that x is cosine. So I'm going to do a substitution. Where the x was, right here, I'm going to replace that with what x equals, cosine. Likewise with y, I'm going to replace it with sine. So we're going to have cosine of theta squared plus sine of theta squared equals 1. And that's how you get this equation. It's by doing the Pythagorean theorem on the unit circle. So now we have 2 others here. These are also known as Pythagorean identities. The reason for this is because they're really easy to make out of this one. So let's take the one that everybody knows, and let's do a couple fancy math tricks to it. So we have sine squared theta plus cosine squared theta equals 1. Let's divide the entire equation by sine squared theta. Okay, so sine squared divided by sine squared, anything divided by itself is 1. So this is 1 plus cosine over sine is cotangent. And you know that from right here. Right here. So if I have cosine times cosine over sine times sine, this is cotangent times cotangent, or cotangent squared. So this is cotangent squared theta equals 1 over sine. What's the reciprocal trig function for sine? Oh, cosecant squared theta. So that's how you make this one right here. If you do the same trick where you divide the whole thing by cosine squared, you'll get this middle one. And if you're thinking, I'm going to have a hard time remembering if tangent goes with secant or cosecant, the cos go together. So cotangent, cosecant, regular tangent, regular secant. But again, if you're not going to remember that, put them someplace you're going to be able to find them, because I can't drive to your house and make sure you're not looking at these while you're taking a test. So what am I going to do about it? Make a reference sheet. All right. Let's talk about one more set of identities, and then we will talk about some tips and then do some examples. Okay. So I'm going to kind of justify these two, and then I'm going to hand wave the other four because they're just reciprocals and whatnot. So this says sine of negative theta equals negative sine of theta. I find it hard to think about things that are generally true or just true for everything. So let's make up a nice example. Let's plug in some numbers to this variable. So let's look at sine of negative 30 degrees equals negative sine of 30 degrees. Okay, so let's first look at negative 30 degrees. That is right about there. So there's negative 30 degrees, which just means we went 30 degrees in the clockwise direction. So 30 degrees would be right here, just going 30 degrees in the counterclockwise direction. So this says sine of negative 30. Remember, sine is the y value of the ordered pairs on our unit circle. So if we're looking at the y value here at 30 degrees, this is going to be radical 2 over 3, or radical 3 over 2, pardon me, 1/2. If we look at negative 30 degrees, this is still a long x and a short y. So this is going to be radical 3 over 2, negative 1/2, because now we're going down on the y-axis. So it says if I plug in a negative angle, it's the same as the positive angle, switch the sign. So if you go in a positive direction, figure out what's the y value at that angle, 1/2. If I plug in negative, this same angle, I'm going to get the same number, but negative. And you can check this for any angle you want. Like you could do 120. So this would be negative 1/2, radical 3 over 2. If you go negative 120, you can see you're going the same x distance, negative 1/2, but now we've gone down, so it's radical 3 over 2, but negative. So what you can see here is if you go a positive angle and a negative angle, their x's always match and their y's are always opposite signs. So that's what these two are trying to tell you. Their x's match. If you plug in negative an angle, cosine is the x, it equals cosine of that same positive angle. So x's match. And then sine is y. Sine of a negative angle is the negative of that positive angle. So y changes sine. Ooh, sine has like that. Okay, that's what these are all saying. So basically, if I have a negative in my sine, I can just bring that negative to the outside as a coefficient. And if there's a negative in my cosine, I can just get rid of it because it's the same as positive. The same thing is true for tangent as is sine, because tangent is sine over cosine. So the cosine, which is whatever, and then the sine changes sign. So tangent changes too. Because cotangent is just the flip of this. Flipping something doesn't change its positive negative. So they're the same. Cosecant goes with sine, so it changes. Secant goes with cosine, so it stays the same. Okay? So these ones, if you think hard enough about them, you can get them. But that's kind of true of any identity. But maybe write them down. All right, so what we're going to do today is we are going to try and simplify some problems. And what we mean by simplify just means cancel stuff out and reduce, and that's it. Because there's no equal sign in any of these problems, you're not solving for anything. You're not trying to get a variable by itself. We are just trying to make it more simple by canceling things out and replacing long expressions with shorter, more compact ones. Okay? Our goal is to make things look simpler. Okay. Here are 4 tips that are not, this is not a Bible. This isn't like thou shalt factor out trig functions, commandment 1, and if you don't, we're going to take you out in the middle of the lake and throw you overboard with the guy that discovered radical 2. These are just tips for things that you can try that might get you to the right answer. They might not. They might make it worse, but at least it's somewhere to start, right? So my first tip is try to factor out trig functions that have big exponents or are repeated. So if you see something like sine of theta, I'm probably going to omit a lot of these thetas, cosine of theta plus cosine theta squared. There's a cosine here and a cosine here. So just like having x, y plus y squared, you can take a y out of both of these. You can take a cosine out of both of these. And generally that will help you use one of these identities that we've looked at. Okay. My next tip for you is going to be substitute reciprocal trig functions to turn them into the base ones, sine, cosine, and tangent. So if you see a secant somewhere and you can't factor anything out, maybe try turning your secant into 1 over cosine and see if that helps you cancel anything. Something you want to be on the lookout for is if you have a squared trig function and the number 1. It could be plus or it could be minus, but you're looking for these things because of these Pythagorean identities. Notice you have 1 squared squared, 1 squared squared. So if you're seeing ones and a squared trig identity, or a trig function rather, you can probably force one of these things to happen by moving some stuff around and then use one of these to simplify. So that's kind of why this one comes around, the Pythagorean identities. Okay. Then if you're really stuck, if these 3 haven't worked, and this is not, again, this is not the Bible. This is not telling you how to live your life. These are just suggestions. Maybe the Bible is like that. Maybe it is just suggestion. Anyway, I digress. So these 3 tips will not get you through every single problem. Sometimes you're going to have to just try things and not be afraid. And you're going to say, but Barton, what if I'm afraid? Well, then do them while being afraid anyway, right? You got to face your fears. In this lesson, you can't become a math warlock without putting on your big kid chonies and doing some spooky stuff. So you're going to have to try stuff. And if you mess it up, God forbid you don't know the answer right away, you can try again. I promise it won't kill you. All right, let's look at example number 1. So we want to simplify this. Let's go look at our tips. Can I factor anything out? No, there is nothing repeated here. There's nothing being multiplied. There's no exponents. I can't factor this. What's tip 2? Substitute the reciprocal trig function and turn it into the base ones. All right, I do have a reciprocal trig function, secant. So what I'm going to do is I'm going to take secant and I'm going to replace secant of theta with 1 over cosine of theta. So this thing in red brackets is going to turn into 1 over cosine of theta. And because these are just sitting next to each other, this is implied multiplication. So we're going to do times cosine of theta. All right, well, we could put this over 1, multiply straight across. So this is cosine of theta divided by cosine of theta. Something divided by itself is equal to 1. There is kind of a caveat here. Technically, we should maybe say except when theta equals 90 degrees, because then you'd be dividing by 0, and 0 divided by 0 does not equal 1. It's you're dividing by 0. That's bad. You're not allowed to do that. But oh well, we're not too worried about it. As long as you get this, I'm going to be happy for today. Okay. Example 2. All right, this is a whole mess, right? We've got cotangent, cosecant. This is awful. Let's go ahead and turn this into some nicer stuff. Okay. We can turn tangent, cotangent, into 1 over tangent. So let's try that. This bar here is going to be this bar here. This is going to be 1 over tangent of theta. Cosecant is 1 over sine of theta. And now you're terrified, right? This is the spookiest thing you've seen all semester, because this is a fraction in a fraction with a fraction. Oh well, you're fine. Don't worry. Don't worry, kid. I'm going to make it worse. Tangent, all right, this doesn't simplify. Tangent, that can be substituted. Tangent equals sine over cosine. Incredible. So this is going to turn into red fraction bar for the red one, blue one for the blue one, 1 over sine of theta over cosine of theta. Okay. If you don't like this, you can go, wait a second, I've got a fraction in a fraction. Well, then why did I turn this into a fraction to begin with? Let's practice number 4. Try again. Let's try something else. This will work if we're not terrified of fractions, but we're terrified of fractions. So let's back up and try this again. Instead of turning this into tangent, let's maybe go ahead and turn it into its quotient of cosine over sine. That way we don't get a fraction in a fraction in a fraction in a fraction. Okay? Red fraction bar. This is unfortunately still 1 over sine of theta. Okay. Now this we can handle. We can handle a fraction divided by a fraction, because we know if you're dividing by a fraction, you can flip and multiply instead. So we're going to take this, cosine of theta over sine of theta, and we're going to multiply by this thing flipped over. So this is going to be sine of theta over 1. All right, now the sines cancel, and we get cosine of theta over 1, which is just cosine of theta. Incredible. Look how simple this becomes. These are fun. I love these. I hope you're having as much fun as I am. Let's do another one. Oh, no. Okay. This one is a tricky one. Okay. Here, we're going to have to really flex our math muscles on this thing. Okay. This isn't just a simple incantation, an eldritch blast, if you will. This is no cantrip, children. This is going to be a level 3 warlock spell. Okay. Pull up your britches, put on your big boy chonies, and let's do some math muscle flexing. We don't, you know what, let's make some mistakes. Let's almost blast ourselves with an Eldritch Blast just to, you know, get it out of the way. Let's do some sneaky stuff before I tell you the answer, okay? You may be tempted to turn this into its reciprocal trig function. You see a secant and you go, Barton said substitute reciprocal trig function, so I'm going to do it. All right, let's do it. Let's do it. This is 1 over cosine to the 4th. When you're substituting things, the powers will stay whatever they are. Minus, tangent, I can turn that into a fraction of sine and cosine. Sine to the 4th x over cosine to the 4th x. Okay, that's not too bad. But what do you do with this? Well, they both have an over cosine to the fourth x, so I could turn this into 1 over cosine to the fourth x times 1 minus sine to the fourth x. Okay, and at this point, we're just running ourselves in circles. This is not helping us. You know, we may have run into a wall here. We may have goofed, but we're going to try again. Okay, so this doesn't look like it's getting any simpler. And do you see what we're going to do here? Because I certainly don't. Okay, so sometimes in your math career, it's helpful if someone gives you a little guidance. So I'm going to show you a trick that you know, but you don't know you know. Let's refresh a little bit. If we have A plus B times A minus B, and we multiply these things, we FOIL them, we get A squared minus B squared. Okay. Do you recognize secant to the fourth x as secant squared x squared? Okay. This is A squared. Tangent to the fourth x equals tangent squared x squared. This is B. So we can factor this thing the same way you know how to factor a difference of squares. This is going to be secant squared x plus tangent squared x. And then this is going to be secant squared x minus tangent squared x. Okay, wonderful. Now, this isn't any simpler either, but let me show you some more tricks. Oh no, I think there's gunfire outside my house. Ignore the gunfire, it's fine. It's just, you know, people are just excited. They gotta go pop off a few rounds to keep rent low. Hold on. Pardon. They weren't gunshots. They were fireworks. Someone was celebrating. My mistake. So, as I was saying, notice we have a bunch of trig functions squared. This is maybe an indicator for that. Look for a squared function and a 1. Well, we don't have the 1. We have a squared function, but let's look anyway. So we have secant and tangent. Let's maybe rearrange this equation a little bit. 1 plus tangent squared theta equals secant squared theta. But we can subtract the tangent squared over. Okay, I'm going to omit the thetas just for simplicity. Equals secant squared minus tangent squared. All right. So secant squared minus tangent squared equals 1. Secant squared x minus tangent squared x equals 1. So this entire thing here, this is 1. And 1 times anything is the anything. So we can just get rid of this whole section. And now we have, let me make this a little skinnier, secant squared x plus tangent squared x. And this is one of the problems that I think we run into with simplification is, am I done? Well, let's maybe put a box around this thing so that we are going to save it. Let's play with it a little bit more because that's how we learn. But if we're done, we're done. So let's maybe just peruse and see what we can do with this. All right, we could turn this into cosine, 1 over cosine squared plus sine squared over cosine squared. And then we could add these because they have the same denominator. So we could do 1 plus sine squared x over cosine squared x. None of these are nice identities that we can do substitution with. And because it's not something squared is subtracted, we can't really factor anymore. This, to me, is less simple than this. So, unfortunately, this blue box, secant squared x plus tangent squared x, that's about as simple as we can make it. So we'll leave it there. On your homework, I will make some sort of questions where it's not maybe so arbitrary. You know, when you're doing these out of a book, I think it tends to be something along the lines of simplify this thing, and then you look in the back of the book and you go, I didn't get that answer, but maybe you got this answer. It doesn't mean you're wrong. It just means you did some more steps than what the book wanted you to, but we're not going to worry about it so much. Your homework will be things more like which one of these is equivalent, and as long as you mess around with it, maybe I stop here and this is the answer. Maybe we stop here and this is the answer. But as long as you can play with it and get to one of them, you'll be able to find the answer. I wouldn't worry too much. It's really about the journey, not the destination. All right. This one, I promise, is much simpler. And then this one is a little more complicated. So here, this is just maybe for the sake of fiddling with the even odd identities, these ones. So we have sine of negative x. Well, we have an identity for that. We can make this negative sine of x. Okay. Cosine of x, we can just get rid of the negative. So this is now cosine of x. Okay. Now, this negative, we can either put it on the top, we could put it on the bottom. These are just principles of fractions. Or we could put it out in front. What this means is 1 times sine of x over cosine of x. Okay, let's ignore the negative 1 for a second. What is sine over cosine? Tangent. So we have negative 1 tangent of x. Oh, that's not what I wanted. Back up. Put a box around that. So this thing can be written as negative tangent of x, which is maybe handy. So there we go. That one's kind of fun. All right. Now this one I think is probably easier than this because there's a very clear, obvious stopping point for us. This one will simplify very nicely, but it's going to take a lot of math muscle to get there. So just try hard, believe in yourself, and don't get too scared. Don't pause the video. You know, just keep your eyes open. Don't look away. You might learn something. So first of all, there are no trig identities that we can apply right now because cosine, the only thing I could turn that into is 1 over secant. And I don't really want to put a 1 over secant in the bottom of a fraction anyway. So that's not going to be helpful. What we're trying to do here is add these two fractions together. So if you have 1 over 2 plus 1 over 3, what do you need to do to be allowed to add these? Well, we need to get a common denominator. And the way we would do that is we would multiply this fraction by this denominator on the top and bottom. And then we would multiply this fraction by the other denominator on the top and the bottom. So let's do that. So we're going to multiply this fraction by 1 minus cosine. And I'm going to omit the thetas. They're there, but they're not important. They're not going to change. They're going to be theta forever. So I'm going to just put theta in the answer whenever we get there. That's not necessarily something you can do 100% of the time, but in this problem, it's not going to be such a big deal. Once you are level 15 math warlocks like myself, you'll be able to tell when you can do that. But for now, just trust me. All right, so here on the top, 1 times anything is the anything. So we have 1 minus cosine over, here we need to FOIL. So 1 times 1 is 1. 1 times cosine is cosine. Negative cosine times 1 is negative cosine. These are conjugates, so the middle will cancel out. So what we're going to do is we're going to multiply the first terms and we're going to multiply the last terms. So negative cosine times cosine is negative cosine squared. Plus 1 times anything is the anything. 1 plus cosine over, we've already done this problem, 1 minus cosine squared. All right, so let's go ahead and add straight across. So 1 plus 1 is 2. Negative cosine plus cosine cancels each other out. So the top becomes 2. And then on the bottom, that just stays the same, right? We keep our fractions the same. So this is going to be 1 minus cosine squared. And if you want, you can put the theta in. Of course, there are thetas here, but omitting. All right, we are almost done here. 1 minus cosine squared theta. Oh, look, we have a 1 and a trig function squared. Let's go see if we can substitute that with an identity. All right, so the identity that we know that has those two things in it, the cosine squared and the 1, is the base Pythagorean theorem that everyone knows. What we have is 1 minus cosine squared theta. So let's move this cosine over to be with the 1 by subtracting. So we're going to do minus cosine squared minus cosine squared. Okay, so we have sine squared theta equals 1 minus cosine squared theta. So we can take our 1 minus cosine squared theta and substitute it for sine squared. So let's go do that. So this is going to become 2 over sine squared theta. So you might want to leave it this way. This is okay. You have it as a fraction. If you are terrified of fractions, remember, we can turn this 2 times 1 over sine squared theta. 1 over sine squared can turn into cosecant squared. So this could also be written as 2 cosecant squared theta. This is probably the better one because there's no fraction, but there's a reciprocal trig function. So, 6 of these, half dozen of those, it's whatever. They're the same thing, they're equal, but it's whichever one you like better. So hopefully this introduction to using trig identities to simplify things isn't too terrifying for you. I hope you maybe even think they're a little bit fun, but I understand that I may be the weird person here who enjoys this. But it's like my mom always said, don't discount anything until you've tried it at least 5 times. All right, I'll see you guys in the next video.